Okay, so we're starting with problem 32 here in the packet. We did a little bit of this the other day. Main thing I stressed with you is where you can be. So like on this one, inverse sine, where can you be? Sine only is allowed here to here. And does it touch or does it not touch? It does touch. So sine can touch right there and it can touch right there. And so I can't use this and I can't use that, but my answer could be on these quadrantals or in these two zones. All right, so that narrows it down a little bit. Now I'm going to rewrite it. Sine of an angle is root 3 over 2, and that tells me sine is positive. That narrows it down further. Can't be here anymore because sine wouldn't be positive there. Now I draw my little picture, and I figure out sides opposite over hypotenuse. Opposite square root of 3. Hypotenuse is 2. This must be L1. What's across from the square root of 3? That's the 60. Therefore, the answer is 60. Or you could say pi over 3. Question on that one? So theta, final answer, would be 60 degrees, also known as pi over 3. All right, so let's do the more complicated kind like this. Now sometimes you can cancel those and sometimes you can't, and I suggested you just never even try to go, oh, cancel, and the answer is pi over 4, because we usually set it up so that only works like half the time. So let's start from the inside and do it that way. Don't even worry about how it's an inverse problem yet. It's just cosine of pi over 4. There's only one place that pi over 4 really is. 1/4 of pi. It's right there. If I'm going to do cosine of that, I go, okay, then I know that's 45. And that must be 1 square root of 2. Cosine's adjacent over hypotenuse. Adjacent is 1. Hypotenuse is square root of 2. It's 1 over square root of 2. Are you with me so far on that? Okay. Now, it's cosine of a triangle where you have 1 over square root of 2. Well, one of the things you got to start with is, am I allowed to be there? Where I have my triangle right now, is cosine allowed to be in that zone? It is. Cosine's allowed from here to here, so I'm okay to have my triangle where I have it. And cosine is positive, see? Cosine of an angle is positive 1 over root 2. Therefore, if cosine is positive, I couldn't be there anyways. So, that brings me back to the same triangle I had before, which now is asking me for an angle. Well, angle 45, so it's pi over 4. So this is one of those where you would have been able to cancel. When would it ever not work out? A lot of times it ends up being something where you're forced into going into a region where inverse cosine isn't allowed. Because see, on this first one, there's no reason you couldn't go into any place because it's not an inverse problem. And you end up drawing your triangle in there, but then, oh, you want an inverse cosine of that in an area where you can't do it. So that means that the answer is undefined. Or sometimes the answer is correct, but in a different quadrant than you drew it in the first place. Anyway, don't just cancel this. All right, let's look at I. Cosine of 7 pi over 4. Would you probably try to figure out what 7 pi over 4 is, and then figure out what the angles look like? And once you get your triangle all drawn with angles, then you'll be able to know the sides. Get it all drawn, and we'll see what happens. Would you agree that 7 pi over 4 puts me right there? Is that what you guys had? Okay. So then, if these are pi over 4s, that's also known as 45. So then this is cosine adjacent over hypotenuse. On this would be 1 square root of 2, and adjacent hypotenuse 1 over square root of 2. Oh wait, yeah, these are both positives, right? That one's negative, so as long as I didn't do sine, I'd be fine. Okay. Now, can I just use this same triangle? No, this is one of those cases where I would have been burned just canceling out the two cosines. If you look, this is where cosine's allowed, and I'm not there. So I have to redraw a new triangle, and I rewrite this and say cosine of some angle is 1 over square root of 2. So where can I draw this? Where cosine is positive, and where inverse cosine is allowed. Inverse cosine is allowed here and here, so it can't be there, can't be there. And cosine's only allowed, or cosine is only positive right here. So I got to redraw my triangle right there. 1, 1, square root of 2, and the angle is going to be positive pi over 4. If I had just canceled them, I'd have thought the answer was 7 pi over 4, but it would not have worked. Okay. This kind, I think, is worthy of going over. 33a, totally different. It's where they give you a side that is just x. Think for a moment. On number 33a, how is it that they actually gave you two sides? They're giving you sides of a triangle in this problem right here. How did they actually give you two sides? X over 1, you are correct. So now I know one of my sides is 1, one of my sides is x. I suggest a rewrite. That gets rewritten as tangent of some angle is x over 1. Now I draw my picture. Am I doing an inverse problem? Yes, I am. So where am I allowed to be? Tangent's only allowed here to here. Can't be there, can't be there. Okay? Now, I would suggest you always draw these in quadrant 1 because you don't know if your x is negative or not, and therefore, why mess with any other quadrant except the one where you know everything works, everything's positive, every function can be in this. Sine, cosine, and tangent inverses can all be in the first quadrant. Okay, so anyway, tangent, opposite, adjacent, there. Am I going to have to find that last side? Yeah, because they're going to make me do sine of this. Sine's opposite of hypotenuse. I'm going to need the hypotenuse. Then you say, okay, this is square root of, and then x gets squared and 1 gets squared, x squared plus 1. There, I got all the sides. You can't get it from here. Find sine, then there's no hope for you on these kinds of problems anyway. That's the very easy part. Okay, let's move on. And again, I'll help you individually if you want, but I'm not stopping for the group. Let's look at the next kind. A lot of people got confused on 34, but before you go think too deep on number 34, if they have given you tangent and they want the cotangent, and you know those things are flipping sisters, and I tell you it's actually pretty easy, you get that it's really 5.32 over 1. And those are flipping sisters. You should be able to get it from there. Okay, the next one. Rewrite as a log. On number 35, it doesn't have a log. You've got to make it have a log. So, how do I make that kind have a log? I just rewrite log base 5, and then it goes around to here of 125 equals that, 3. That one confuses people sometimes too because it doesn't have a variable. All it is a fact. It's just a fact. This does equal this. So there's no problem to solve here. It's just a true statement. They just wanted you to write it as a log. So there, it's a log now. All right. How about an ln? Immediately change that to log base. Then you can rewrite it from there. E to the yourself. Okay, so rewrites on logs should be easy for you. It's like the easiest kind of log problem. We got convert to degrees. You're either in this whole little section here on 38 A, B, C, D. I guess it's just A, B, C. All you got to do is either multiply by 180 over pi or pi over 180. And how do you know when? You'll have stuff cancel if you do it right. If you don't do it right, it cancels. So for instance, if I have pi over 180, the pi's aren't going to cancel each other. They're going to be pi squared. That's going to be weird. So I obviously am doing it upside down. Change it to 180 over pi. So multiply by the right thing. Same thing with this. You either multiply by 180 over pi or pi over 180. Same thing on 39. A and B. A lot of people ask me about this next one, coterminal. Coterminal means that they end in the same spot. So what are coterminal? Like cohabitate means you habitate in the same spot. Coterminal means you terminate in the same spot. So as you're going around the circle, if I said here's a spot, what else ends there? Well, you could say pi over 4 ends there, or you could say 45 degrees ends there, or you could say negative 315 degrees ends there, or you could say positive 360 plus 45, which would be 360 plus 45 would be 405. 405 degrees ends there. The point is, a lot of things end right there. I was making one up. Now let's do one that's actually real here. And I'm sorry, I scrolled it too far down. What I was talking about is a coterminal angle one. Sorry. There we go. So how do I get something coterminal to 510? Well, first of all, where the heck's 510? Here's 360. 510 is a little further. Specifically, I think it's 150 degrees more than that. Can anybody verify that? 360 plus. All right, good. So if that's 150 degrees more than 360, then tell me another way to get to that spot. It's like my cabin's in Wisconsin. I can either go Minnesota way to get there, where you go mostly in Minnesota at the very end, you cross over to Wisconsin, or you can drive over into Wisconsin and then drive all the way, the rest of the way through Wisconsin. I got two ways to get there. How about this? I can get there by doing 510. It goes past it and comes back. What's another way to get to that green spot right there? 5 pi over 6. Ooh, fancy. Changed it to radians. So yes, this, to get here, you could do 5 pi over 6. That's one thing that's coterminal with it then. What's another way to get there? Please say a negative answer. Negative a whole bunch of pi's over 6's. 6 pi over 6 will get me to here. And is it one more pi over 6? I think it is. 7 pi over 6 is good. Okay. Great, negative 7 pi over 6. And then we get whatever the number of degrees that is. We could do that. 180 plus another 30, 10. I think it's negative 10. Okay, so it's just a lot of different names for the same spot. That's what coterminal. Terminate in the same. All right. Next little part's about reference angles, and oh my gosh, so should be the easy part. Just reminds me to remind you that not the whole final isn't all hard problems. Some of them are easy. Draw the reference. Does that say angel? I think it does. I think it's supposed to be LE, but anyway. And find its value. All right, so first I got to figure out where 14 pi over 3's are. Well, where's 1 pi over 3? It's like that. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3 of a pi. And then all the way around it'd be 12/3 of a pi, it'd be here. 13/3, 14/3. There. That's the spot. That's 14/3. Now what do I want? I want to draw a triangle and figure out the reference angle. So I draw my triangle, boop, boop, and the reference angle is that one. And you got to figure out how many degrees it is, or radians it is. And these are all based on pi over, what's pi over 6 is pi over 3? Pi over 3. So then that's a pi over 3. Pi over 3 is the reference angle. Triangle is just a little red triangle that goes with it. Okay, these next are all about using identities. I gave you that list on the front page, and you're going to need to refer back to that. Question before we go there. What are you talking, 42? Okay, I don't want to quite go that far yet. I want to look at this first page. So I'm going to remind people about 42A, the simplest of them all. So what on your sheet, there's only a couple places where tangent comes up. on your sheet, tangent, pull up in your memory banks. It's almost like a global search. Think, okay, wait, search of the identities file of my brain. Which of them say tangent? Oh yeah, I got tangent is what? 1 over cotangent works, or there's something better. Sine over cosine. So I'm going to say I had a couple choices, but I'm picking sine over cosine because cosine's in it, and that's going to make this cosine cancel. Just brought that down. Then that'll cancel that. So it's just substituting, pulling things off your memory files. If you don't have these memorized, you need to do that. That is something you should spend time doing. I see this, and right away I say, oh, there's an identity for that. And I know that's the cofunctions one, like sine and cosine, tangent and cotangent, secant and cosecant. All right, so what goes with sine? Cosine. So that gets replaced with cosine of y. That thing right there becomes cosine of y. If you just have it memorized, you have it memorized. Secant, remember how generally good advice is change everything into sines and cosines? What is secant saying? 1 over cosine. Now you got 1 over cosine times cosine, and that's going to work out real nice. Okay, so, and now you ask me about what letter? H. Okay. So you got to look at that and start pulling through your memory banks. Which of the identities has got a cosine cubed in it? None of them. So then something's wrong. One of my favorite math truisms. You can factor it, you should. So tell me what the factor. Cosine theta comes out, what do we got left? Squared, yes? And then isn't this on your sheet somewhere? Cosine squared. There's only one spot where it is. Pull up the memory bank. Sine squared plus cosine squared equals. Yes, this is your little one that has cosine squared in it. And I strongly recommend that's exactly what you do. You don't try to jump right to the answer. You just, what was that fact again? Oh yeah, that's the fact. Now, do you get, if I were to move this over to the other side, I'd have 1 minus cosine squared? And that's exactly what they want, 1 minus cosine squared. So I just move that over to the other side, and sine squared will be equal to 1 minus cosine. So this must be sine squared. Tell me. Generally, if you've turned it all into sines and cosines, nothing else is canceling, probably done. Now, I can't see anything else to do yet, but I'm going to look a little further. Searching memory banks for cosine. What are my options? 1 over secant. Would that help at all? Searching memory banks for sine squared. Only thing I got is 1 over, what's the 1 over for sine squared? 1 over cosecant. Is that going to help at all? It's not 1 over cosine. So, can't simplify it anymore. That's it. I know it's hard to tell, but you just have to go through everything in it and see, can I substitute anything for that? And if so, would it help? Can I substitute anything for that? Would it help? And don't forget those little truisms, like if you can factor it, you should. That is your answer, right? Usually they simplify down to something like a single item, like 1 plus cosine, or maybe tangent, or whatever. But this one got 2 things in it. Can't fix it. All right. These are your toughest ones. And I can't just answer them all for you. You've got to pull them up off your memory banks, which right now you can supplement your memory bank by looking at your front page where we wrote them all. But, you know, and if doing something like this, right away I think common denominators. If I could get these guys to have common denominators, I could actually add them or subtract them. So to get a common denominator, maybe I should simplify these a little bit first. Maybe I can get secant, which is 1 over cosine. That doesn't really help me, though. Or maybe I could simplify this over here. Sine over cosine. Well, sine over cosine's tangent. That's kind of cool. I could make that sine over cosine into a tangent. Another option, I make the sine over cosine into a tangent. Maybe what if I could make the other one into a 1 over tangent or something like that? So separate this one out for just a second and say 1 over cosine over sine. And then I flip and multiply. It's a 1 over the 1, and I make it 1 over cosine. So that's going to be 1 over cosine sine. Okay, guess got to do the common denominator. Nothing's working out nice to simplify, so I'll just do common denominator, and it's a good review problem anyways. There is going to be common denominators on the test, so let's deal with this one. You can always get a common denominator by multiplying by the other denominator. So I'm going to multiply this by sine over sine, and I'll multiply this one by cosine over cosine. And the sines could cancel back off again, but that'd be dumb. We just put them there. And we wanted a common denominator. Okay, so now I've got a common denominator. My denominator is cosine sine. And what do I have on top? A cosine secant. And that's going to work out nice. Because cosine secant, you know how secant turns into 1 over cosine? Remember how secant turns into 1 over cosine? That's going to be pretty slick. Because cosine times 1 over cosine. I'll just here quick. And then minus sine times sine, sine squared. So this turns into 1 minus sine squared on top. And you know what 1 minus sine squared is, I hope. Go back to that one thing I know about sine squared. Cosine plus sine equals 1. So sine squared. And then 1 minus sine squared. That's the other side. 1 minus sine squared, same as cosine squared. So basically, I got cosine squared on the top. Over cosine sine. And then these can simplify a little bit. Cosine squared over cosine, reduce. And in the end, you can get this down to one function. You have to figure it out from there, yes. All right. This part right here. What's cosine? Cosine's cosine. I guess you could make cosine into what? Another option for cosine. 1 over secant. Well, that actually could work. 1 over secant times secant. So that would work. Or the other one would have worked. You could have taken secant and making it 1 over cosine. But either way, these are inverses of each other that are getting multiplied. And see how they end up canceling and making a 1? Okay. Pull up out of memory banks. What's sine squared plus cosine squared? Ah, so that one's easy. 1 over cosecant. 1 over cosecant. Have that in your memory banks too. Flip cosecant. 1 over cosecant. All right. Okay. And that brings us to the sum and difference identity. The very last thing we're going to tackle today. And then you have much work time. So sine and cosine have little rules. They're on the front of your packet. Everybody flip to the front page. And that page, it's going to happen during the final. Imagine for a moment you're going to get to this problem. And you're going to go sine of a really tiny degree. Or a weird degree like sine of 75. Something you can't do normally. This is either two things added together or two things subtracted. So you're going to change that to sine of two things. And now just think for a second. If you can only know 30, 60, and 45, those are the only numbers you could use. Do you want to add two of those numbers to make a 15? No. You obviously need to subtract two of those numbers to add up to 15. So what minus what? Give me 15. 60 minus 45 or 45 minus 30. Either one of those would actually work. I'm going to use 45 and 30. Do you get what I just did there? You just changed sine of 15 into sine of 45 minus 30. Nobody could argue with that. It's just 45 minus 30 is 15, so okay. Now why is that any good? Because if you look at your formula, it'll tell you how to calculate sine of 45 minus 30. And I think it goes sine, cosine, cosine, sine. And And then what are my two angles? 45 and 30. 45 and 30. And then the last thing on your formula, it has either a plus minus or a minus plus. If it says plus minus, it means use the same sign as you were using in the first place. I was using a minus, so I got to use a minus. If I was doing cosine right here, if that was a cosine problem, I would have been using the opposite sign of whatever I did. So I used a minus, so I would have had to put plus here. I would, had to change sign. But on the sine one, that's going to be a really common mistake. Some of you aren't listening right now. There's a minus plus and a plus minus. If the formula uses the same symbol at both spots, it says plus minus and plus minus, then you use the same symbols there. When it's the other formula, cosine, it uses the opposite formula. So whatever you used in the first part, change it to the opposite one. So if you start with plus, you use minus. So on this problem, you'll have to do that. Here, since I used a minus to start with, I'm going to continue to use a minus. Now, I'm not done yet, but I am left with 4 really easy little trig problems. What's sine of 45? Draw myself a picture. 1/3 of 2. Sine of that is opposite over hypotenuse. I'm going to pick up this thing to go from. They're both the same, so it wouldn't matter I use that or that. Opposite of 1 over hypotenuse is root 2. This is 1 over root 2. And I'm timesing it by cosine of 30, which I have not got memorized. So with sine of 30, I'd have it memorized. But cosine of 30, I'm going to go to this triangle. 30, 60, 91, 2 square root of 3. Okay? And then cosine of 30 is chi, adjacent over hypotenuse. Adjacent is root 3 over 2. Here we go. Then I'm subtracting this part, cosine of 45. Ooh, I already got the triangle. That'll be easier. Cosine, adjacent over hypotenuse, 1 over root 2. And sine of 30, sine's opposite over hypotenuse, 1 over 2. Ooh, I knew that one. Sine 30 is a half. There we go. And now notice they have a common denominator built in. 2 root 2. 2 root 2. So now I can just subtract them. The tops get subtracted and it's all over the common denominator of 2 root 2. What was on tops? 1 root 3 minus this, that, minus 1 times 1. Root 3 minus 1. There you go. Okay, that's how to use the sum and difference identities. What's the other one that you had to memorize that they didn't make you regurgitate yet? Cosine of 2 theta you did not have to memorize because it's on the package. It's like that. Sine of 2 theta. But just imagine the final was right now. What's sine of 2 theta? 2 cosine sine, or 2 sine cosine, it does not matter. So sine of 2 theta is 2 cosine theta sine. Get that one memorized? All right. That's all I want to do with you today. Just in case, this other section is kind of the same, but a little different because it's scarier because it's got radians in it. How am I supposed to do that? It's a sum or difference identity. It's the same exact thing as we just did, except I'd figure out what pi over 2 is, 5 pi over 12 is in degrees. I change that to degrees. You're going to find out it's some big number, like 105 degrees. Then you might be like, so what am I supposed to do with that? Then that is either the sum of a 30, a 60, and a 45, the only numbers you can do in your head, or, it is a sum, isn't it? The 60 plus 45 would make 105. But I didn't say that 5 pi over 12 is 105. I'm just saying it'll be something like that. Did you already figure it out? He thinks it's 75, which probably is likely because what two things make a 75? 30 and the 45. Okay, and those are ones you can do in your head. So this is like sine of 30 plus 45. And that means you got one of those same problems we just did a second ago. You go, okay, that's the sine formula. Sine, cosine, cosine, sine. And it's an add problem. So since I'm doing sine, I keep the same sign. I do plus in the formula. You have to go from there yourself. All right, so we will start with number 44. It says cosine of 2x. It's one of the ones that's on your sheet, so you right away look at the sheet. want to start that section, go ahead. But I'm going to do the rest of this review in our 2-hour session tomorrow. I won't be doing 2 full hours. It's going to be a lot more time for you to ask questions. So if there's any part of the packet that you've had trouble with, go back and ask me. We're going to have at least an hour of that 2 hours at minimum. There's going to be time where you can work, come up and ask questions, all that kind of stuff. Okay, that's all I have for the video for today. Thank you.